Okay, I'm going to show you guys how to start a Pix project after you already download your files from Synology, or just like a brief explanation. You go, I hope you can all see my mouse clearly, but you go to Synology 2LA2 and then find your file locations like under Price Lab, and there's a bunch of names. Find your folders, and today I'm going to start with Isabella's folders. And find your files that is uploaded. So just make sure you being actively as the TA that is on the instrument, like whether when is your samples going to complete and if they have uploaded files for you. So after the upload, your files should be here. Okay, so like today I already downloaded the files I need, and then on this like regular circumstances, it should go directly to the download. So like these are the files I'm going to start analysis today. And so it is a folding project. So it has nine points that you have to put in the same project. So if it is but the same principle apply to any other projects that you need to run MassBet files for. Okay, so here's you go to the Pix Studio, and just like there's 3 computers, and generally we use the number 1 and number 2, and number 3 is dedicated for LibXworks. So try to use number 1 and number 2, and when you choose computer, like just before you start analysis, go to task and check if there's any other project that is running. And since like you can queue up the project, but like your project will not be run until the previous project is finished. So it is just check one that is like will be more available, like less tasks than it need to complete, so that will make you can get your data sooner. Okay, so what you do, go here to start a new project, and the first thing is change the project to your notebook code, and then your experiment name. So like a notebook code, and then a brief description of how can you recognize your experiment. So like here is like IJ is Isabella's notebook, and then E200 is EDTA, 200 molar equivalent in serum. So that is something like if you're on the project, you would know. But having the project, like your notebook code in the front, is important. As like we mentioned before, notebook code is the key for everything. So it helps you recognize what your projects, and also help people to recognize yours project. And this is a project location. I like to just put it in like the D drive and Pix project, and then move it elsewhere if I like to, because one advantage of putting in D drive like Pix project is Daniel Mortensen, like the head of this like MassBet facility, that he will always back it up to the drive, like to this Synology. So you can technically have 2 copies if you constantly back up. So, and the other thing is if you could not find a project in D drive, Pix project folder, then just go to Synology and find it, because like after he back it up, he will delete it. Okay, so that is just save your project and somewhere that you can find it, and then you get to go to the location of your files that you just download. I like to sort it by the modifier so you can easily recognize the files that you need. And then so there's something like, so here's some parameters. The enzyme uses drip sense, and if it is ORB data, you choose ORB CHAP, and CID and DDA under like no more standard run. So if you have talked to the TA about like you have different methods, so you're just going to change this accordingly. And just remember Pix Studio, remember the setting from the last user. So it does not remember the default setting. It remember the setting from last user. So if the last user is doing something different from yours, like your parameter will be different, like the parameter will be different from yours. So just to make sure to change it before, like to make to what you're using. So like if you're on voting group, it is also likely you'll run your samples on IMQTop, an Agilent machine. So you will come here and select Agilent QTop. Okay, but right now these are Orbi data, so we're going to use Orbitrap for now. And easier for you to change it before you push your samples into this box. Okay, so the next thing is just you are going to like push your sample from the left to the right according to the order you want it to be in your output file. So you will find it's a lot easier to just organize it right now than later. So like I'm having a like guanidine concentration curve from 0 to 6. So I start from 0 and you'll use this bottom to push every samples. I'm just going to give a sample like, so if you use this one, like the samples will push into here like individually as 2 samples. So now I'm going to move it back. But if you use the first bottom, that is going to do like combine them into one analysis, then it will become one sample. So I don't know, most of the situation you're going to do it like into different flasks. So like one samples will have like their own de novo files. That is a lot easier for you to have more detail for your sample runs. If you want to group them, like you're welcome. Like it's like you can do group them for quantification at the end of the like at a quantification step really easily. Okay, so add samples, trypsin, Orbitrap CID, and acquisition method DDA. And I'm starting going from 0 and 0.75, 1.5, 2.25, 3, 377, 4, like 4.5, 5.25, and 6. And the next thing you're going to do is you're going to rename it. So, well, depends on your project. You might want have a different like rule for how you're going to name it. For a voting project, we always need to have the concentrations at the end. So that is how I'm going to do it. And so see, like just you don't like this part, you don't have to make it long because like I might show you later, depends on the time of today. Like this one will be like the header of your columns, like for your samples columning. So you don't want it to be extremely long, but you also want it can be differentiable. And then especially if you have multiple Excel files that is opening, you want the column like you will be like you don't want to mess up your samples like conditions run between runs. So having it clear is definitely helpful. So then you go to work selections and sequence database search and go to identifications, go to BYUMS, predefined parameters, just to make sure like nothing is like if somebody have different parameters, you go to BYUMS, that is like usually correct. So like we define data using DDM method and just looking at the precursors with it, there's mass. And then you go to database search. That is the most crucial part. Okay. Under a lot of normal standards, you go to BYUMS, and then there's like our standard runs, and it is something. The parameter is the same as the cheat sheet that next to the like computer monitor. So usually we do like 20 ppm, like arrows tolerance with like 0.5 delta, like deltas. And the samples like is specified each sample from the previous step that we do. And we use undigest, like unspecific mode that allow like noun, lysine, and arginine, like the the cleavage that is not on the digestion site. We allow 3 miscleavage, and this like the PTM that is like this like carbonyl methylations, oxidation, and pyroglutamate glutamate is all like the PTM introduced because of our mass spec sample prep, so they will be here. and using the like define like three ports database and mouse things like we have a lot of mouse words like mouse is a defined, but if you're working with some other tissue organism like human, you just go here and like select human and like the like the PTM settings is like just usually the by default is like search for all the PTM that is built in. So you're going to see like the phosphorylations, acetylation, like those like common signaling PTM. Okay, and just like make sure unless you have a reason that you know you have a contaminant database you want to use, just make sure it is unchecked on the contaminant database. If there's a story about me, like troubleshooting, like why I have less peptides, and like it takes entire summer for me to troubleshoot just to find out. I accidentally checked this box, so just don't do that. And then like you like just make sure you have like uh decoy and PTM and spider that is set up for you, like that will do. And like in another video, I'm going to explain each of them in more detail. But just like select BYUMS is like the first things you want to do if you are doing like a standard run, and that will make your life a lot easy because you can just change your organism. Okay, but for folding groups, like that is listening right now. So you go to predefine and go to like CD iodine on different computer. It might name like folding iodine something, but it's like you can find something iodine there. That is our predefined analysis for a peak, and that saves you a lot of time. So everything is the same: 20 ppm, 0.5 delta, unspecific, 3 miscleavage. But like for most of our folding work right now, like the default like organizing is human because we're working with serum a lot. Later on, you might want to change to mice if it is APOE project or like PC project, but like just for now, just make sure like it's okay just using human. And here, like the difference over CD iodine project, iodine folding project is here. So instead of search for the 312 built-in modification, we only search for this 6 like modification like that is introduced because of iodine. So just making sure that you're doing this. In some cases, if you're doing dimethyl labeling, you might want to like open like allow this PTM per peptides more, turn it up. But for regular iodine setting, just go ahead with like select CD iodine and just come and make sure all the diatomations and sulfonic acid on this thing are there. Just that will be good. Okay, and then the next things you do is after you making sure this, and then you go to quantification. This is where I tell like everybody, if you want to quant your samples, grouping them, you can do it here. And normally, like most of us are doing label free in all our lab. Well, most of like that is standard way to do it. Like of course, like you might go to TNT, and you might need to do dimethyl something else, but like go ahead with label free as your standard. So the same things here. If you want to group them into different groups, like if you want to group them, select one folder. So you can name it as like, okay, condition 1, and there will be your replicate, like through replication and samples. Okay, like something like that. So there's your condition 1 and condition 2. But like for us, for folding projects, it is all like they are independently. So just again, like push it using the double folder 1 according to the order. So 0, 0.75, 1.5, 2.25, and 3, 3.75, 4.5, 5.25, and 6. And then again, just name it again. And now like I just do a simple version, and because like actually, and when you have your output, you will find you have a group and an individual. And since everything is like all the sample is group. So like one sample, each sample is a group. So like you actually will have two set of identical number in your output. That can be confusing. So I just name it a little bit differently for the ID samples and the groups. So I know which one is ID, which is which is ID, which is samples. And then you finish. So for orbital data, one samples take about like 2 hours to get through everything. So I have like 9 samples. It takes about 18 hours ish. So after you queue up your samples, you can come back like just making sure it is starting, the data is loading, and when it is loading, it will have a percentage. And after it is finished, this quarter, like 3/4 quarter of moon, of the pie will be filled up. Like now it's not filled, but when it is 100% data loaded, it will go to a full green there. Okay, so that is how you're going to queue up your analysis, and you'll come back. I'm just waiting for you to see that is going to be 100%, and then it will turn solid green. Okay, well, you know what, as we are waiting for that. And okay, so also this is what you are going to see at the beginning. Like if you see something is running, you can see a procedure. Sometimes some computer, like if the people are actively running analysis, you will see, oh, maybe there's like couple of folder that is queued up, but like none of them are yet running yet have any percentages. That means there's like you will, if you start on that computer for analysis, you will going to be waiting for a bit. Okay, so this is how you're going to analyze, like start your peaks analysis. Okay, well, it is 99%. So like you really want to make sure after you queue up your samples, everything is going to like read in, and then so you will not come back next day and be disappointed that, oh shoot, like it failed. So when it's 100%, you will see it is like a failed circled, and then it starts going to data refined. Okay, so this is how you're going to set up your experiment.